Hello and greetings. Welcome to this project demonstration video. I, Yuvraj Sharma, along with my fellow teammates, have developed a project that is automated creation of SDC file using bash scripting under the guidance of Pine Training Academy. So, before starting with the demonstration, I would like to give you a brief introduction of the project and its parameters. First of all, we will discuss what exactly is SDC file. SDC is the abbreviated form of Synopsys Design Constraint. It is a text file with industry format, specifies the design intent, including the timing and clock constraints of the design. It is used by STA tools, now Synopsys Primetime being the market leader, therefore named as Synopsys Design Constraint. There are several tools that use this format, which is DC, which is Design Compiler, ICC, which is IZ Compiler, and PT, which is Primetime. This file comprises of the constraint used to meet timing requirement of the design. Now, having a look over the flowchart of the project, this project takes a input file name as the input. Now, if the destination file already exists, then the update underscore existing module of the project is called. If no, then the file check underscore new module is called. Now further talking about the update existing module, a list is given to the user with all the SDC extension files, and if the name given to the script is already in that list, then the file is initialized. If no, then the update existing module is again called. After the initialization of the file, a list of commands corresponding to the user requirement are given to add the constraints. Now after selecting the choice and filling up the parameters, if the user wants to add more constraints, then in that case, it asks whether he wants to add more constraint, and user has to give the input as yes or no. If user gives the input as yes, then it again gives the choice to the user and the parameters are added. And if the user has to stop the constraint appending in the file, in that case, the provided constraint commands along with the parameters which are given by the user are written in the file. So this is pretty much the flowchart of the project. Now moving on to the main demonstration of the project. First of all, we'll source the script. The script is named as sdc_creator.sh. Now there's a function named create_SDC in this script. We have given a unique feature in this script, that is when in Linux you put ---- help in front of any command, that gives the description of that command. Now if you give create_SDC ---- help, a description of the script is given to you, what actually the project does and all the module information. You can have a look over the module information and the general description of the project. The module information is as create SDC, set input delay, set output delay, set false path delay, set multicycle path, and many more. So this is pretty much the description of our project. Now starting with the main demonstration, we'll write the name of the function which is in the script, create SDC. Now here we're given two options. First is create new file, second is update existing file. We'll start with creating new file. We'll type 1. Okay, so now the script is asking us to give the file name without any extension. It will add the extension itself. So if we do like ASIC1 and enter, now we have provided a unique feature to this. If our file is already existing, then it will show us whether the file is present or not. Now we'll give the name of the file. As you can see in the green, the ASIC1.SDC file has been initialized. Now we have to add all the constraint commands. Now I'm going to show you the second option, which is update existing file. Now again, writing the name of the function, create underscore SDC. If file type 2, which is update existing file, all the SDC extension file in our current working directory are shown in the as a list here, and we have to select from it. Now suppose I select a file which is not existing in this, namely asic2.sdc, and we have provided a feature which we'll talk about later, asic2.sdc. You can say that what is written in red, if file with given name doesn't exist, please provide name for below files. And again, the file name is the file with SDC extensions are given as the output. Now if I'll type asic1, and I'm just pressing tab now, in that case you can say asic1.sdc is completely typed. This is the feature that we have given to our project. It supports the tabbing of the you can say the content that you write. Now moving on and pressing enter, you can see that the file has been initialized, and it is asking us for the different constraint that we want to add. Suppose the very first constraint we want to add is first, which is clock definition. So it is going to ask, please specify the number of clocks required to be defined. Suppose we take 2 clocks. Now the name of the first clock has to be given by the user to the script. We'll give the name as demo underscore clock underscore 1. Now we have to provide the parameters of this clock to the file. Suppose we'll take the clock period as now all the numeric parameters are given in nanoseconds. Suppose we'll give 50 nanoseconds. Waveform start and end in nanoseconds we have to give, which is 0.00, 25.00. We're keeping the duty cycle as 50% in this. So the on time of the clock will be 25 nanoseconds out of the 50 nanosecond period. Now clock port name has to be given by the designer. So we'll say demo underscore port underscore 1. Now it is going to ask whether we want to do any changes in above clock parameter, yes or no. Suppose we do yes. As you can see, I accidentally typed a bad input. So in that case, it said invalid input, please select from available choices. I can show you by doing it again. So the available choices are 1, 2, 3 and 4. If I type 5, in that case, it will say invalid input, please select from available choices. Now if we want to do any changes in, you can say waveform, I'll just press 3. Now again it is going to ask the value of the waveform. Now let's keep it 60% duty cycle. Clock parameter saved. Now you can see that it is asking for the parameters of the clock number 2. As before we started with the number of clocks to be 2. Now we'll give demo underscore clock underscore 2. Now again we have to give all the parameters of that clock. So let's do it quickly. Waveform, clock port name, as we have seen this option already, we'll just say no. No changes made, clock parameters saved. Now it is asking, do you want to add more SDC constraint? As you can see in this way, is in this wave flowchart. This is add more constraint, yes or no. So we'll just type yes. Now let's move to this clock latency in propagated clock. Now we have to provide latency value of demo clock 1. Now our project uses array defined module, which creates an array and saves all the parameters like clock name and clock port. So the index of that array is clock name, and the value of that array is called as clock port, and we have used both of them simultaneously. Now as you can see, that array is used here and provide the latency value for clock demo underscore clock underscore 1, which is the name we defined earlier. Now latency value, let's give it 1.00. Latency value of second clock, let's give it 2.00. The propagated clock command does not require any input from the user, so they are written automatically. Now it is again asking, do you want to add any more SDC constraint? Now we'll say n, and we'll have a look on the file which we have created. Now you can see, we'll just list all the file with SDC constraint. At the end you can see async1.sdc, and we'll just have a look at it. As you can see here, the clock definition commands have been added in the top two lines, which is create clock, these. And the latency command, which we gave the value as 1.00 and 2.00, has been added after that. And the set propagated clock, which uses the port name of the clock defined simultaneously to the clock as its input. As you can see here, in the first line, the period we gave is 50 nanosecond, the waveform we gave 00 and 30, and the port name is given here, this one, these. So as you can see, this file is thoroughly updated and according to your inputs given to the script. Now closing this file, and again sourcing a script, not sourcing exactly, just giving the module name, which is create SDC. Now let's move toward, as you can see, the second option, update existing, we have to continue with that. So again the file with SDC extension is given, let's say 1. Okay, sorry, as you can see, this also supports the error redefinition. If we give anything instead of the name that are already given as the output by the script, it will give a message which is file with given name doesn't exist. Please provide name from the below files. Now I'll give just async and just press tab, and the full file name will be given. Okay, so now it is going to ask the constraint list. Let's put up 3 this time. Now there are two options in setting the uncertainty. The uncertainty is set between all the clock pairs. That is, if you have provided 2 clock names, in that case there will be 4 clock pairs. So the clock 1 along with the clock 1, the clock 1 with the next clock, that is clock 2 with the clock 1, and clock 2 with the clock 2. So let's do it automatic this time. The automatic feature is giving the same value for uncertainty to each clock pair. Let's give it 5.0. As you can see in the next line, force uncertainty command were written with the value 5.00 between all clock pairs. This is the automatic. Now talking about the manual, you can say each clock pair uncertainty is defined separately. And the next question arises, that is, do you want to add any more SDC constraint? We'll say yes. Okay, so for now let's move on to input output delay, which is 4th. As you can see, this array set module is used, and the output is given as the names of the clock. You can say here, these are the names of the clock which are given using that array set module. So secondly, let's go for first input delay. We have to provide clock name, demo clock underscore 1, delay value, let's say 0.5 nanosecond. We don't have to give the unit, it already provides the unit to the file. We have to give the port name, let's give demo underscore port underscore 1. Do you want to add any more IO delay? Let's say no. Do you want to add any more SDC constraint? Let's say yes. Now the min-max delay and input-output delay is for the similar to each other. So we'll just move to sixth option, which is false path. As you can see, we are given three options on giving the constraint command of false path, which is setup, hold, and default. Let's go for setup for first. Now we have to select from option from, through, or to. Let's say from. Now we have to specify the domain, which is clock, whether we have to add false path for clock or pin or port. Let's say clock. Now you can say the clock names are given already. Let's say number of clocks that we have to define, let's say 2. Now we have to give name, which is demo clock underscore 1. Clock 2 name, demo underscore clock underscore 2. Now it is going to ask whether we want to add any more options. Yes. Now we have to use because the false path acts from to, that is from any pin to any pin in the design. So let's go for 2. Now let's say we have to declare a false path from a clock to a pin. Let's say pin. Let's provide number of pin. Let's say 2. Pin 1 name, pin underscore 1. Pin 2 name, pin underscore 2. Do you want to add any more option? Let's say no for now. Do you want to add any more false path constraint? Let's say no for now. Do you want to add any more SDC constraint? Let's say yes. Now the final, which is multi-cycle path, is left. Let's do it. It is also same as setup, hold, and default. Let's do it for hold. Multiply path value, that is, you can say the multi-cycle path is like increasing the setup. Like suppose our design is not meeting any setup. In that case, we just provide multi-cycle path to that particular pin so that it can satisfy the setup condition in next path. So let's say the multiply value is 2. That is, we are capturing the data. We are taking the setup condition on the second clock. It's a second, you can say the second edge of the clock. Now we have to again select an option. Let's select from. Specify the type of domain. Let's say in clock. And let's say specify the number of clock as 1 and give single clock name, which is demo clock 1. Do you want to add any more option? Yes. Now we have to select from, through, or to. Let's say 2. Let's say clock again. Let's say port this time. Specify the number of port, 1. Name of the port, port underscore 1. Do you want any more option? No. Do you want to add any false path? No. Do you want to add any more SDC constraint? Now we have completed the constraint list, so let's say no. As you can see, the last message shown is file saved. So let's check what we have created. JVM asterisk. All the SDC constraint file which we will be given here. As you can see, this is the ASIC one underscore dot SDC that we just created. Now moving on from the set clock uncertainty, this section that we defined afterwards, you can see the first clock uncertainty that we gave was automatic, the value of 5. So you can see here that 4 clock pairs have been given the value of uncertainty. Demo clock 1 to 1, demo clock 1 to 2, demo clock 2 to 1, demo clock 2 to 2. And the value of them are 5.00. Now, next is input delay. As you can see, the command is written to the corresponding. We have given the value as 0.5 and the demo port is given here. Now, talking about the next command, which is set false path. You can clearly see from here we selected the setup option and multiple clocks, which is from get clocks demo clock 1, get clocks demo clock 2 to pin which is pin 1 and pin 2. And multi-cycle path is given the multiplier value of 2, and in case of hold, from clock 1 to port 1. Now talking about the features of our project, you can say that this project creates synopsis design constraint file in a nutshell. And second feature could be its redundancy minimized, as the file contains the redundancy of command. Only a set of values are taken from the user, and the corresponding command containing those values are appended in the main file. It is time efficient. It saves a lot of time. It just takes the value from the user and just appends that in the file. So as it provides an interactive method of eliminating redundant approach. So it also follows recursive approach. What we have done, we have encased each case command in a particular, you can say, function, which is later on called in the default option of that case, which supports recursive approach. And last but not the least, it is faster process for writing SDC file, as it just takes value from the user and all the commands are appended in the file. Now talking about the future scopes, you can say there is no dedicated tool available for the writing of SDC file, so the escalation of the project in a constructed approach is possible. We haven't added all the commands that supports SDC format, so furthermore command could be added. And we haven't enabled the modification in midst of any constraint in any section, so that could be achieved later on. And it is beneficial for STA's ingenious profile. So thank you so much for your attention and precious time, and I express my gratitude towards Spine Training Academy for providing this opportunity. So this is Yuvraj Sharma signing off.